Yeah, last lesson before we do Thursday stuff, relations and functions, okay? Functions and relations, it's a very, very simple lesson, okay? I'm not gonna really talk about this one much, but I'd rather get to the nitty gritty, the meat of this lesson, okay? Notice how we've got 10 desks, and I can make 2 rows of 5. I can also make 1 row of 10, for example. All right, 1 row with 10 seats, right? So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all in the same row, right? Bing, bang, boom. There you go. Okay, so we're basically making groups and relations between this. Okay, so again, I strayed away from this because I want to focus more on this. Domain and range. Domain represents X. Range represents Y. Very important. Okay, and when we make tables, we make relation between this, okay? A relation is a set of ordered pairs. So for example, 1 comma 11 is 1, 2 comma 12, 3 comma 13, and then vice versa, okay? A function, and this is the mathematical way of saying this, a function is a relation in which each input is assigned to exactly one output. In other words, for functions, the x's cannot repeat. In other words, the x's cannot have more than one answer. If it does, it's not a function. Domain, as I talked about, is the inputs or the x's. Okay, range are the outputs or the y's. Okay, here we go. Let's identify the domain and range. Remember, domain are all the x's. Well, here you go. 2, 3, 4, 5, 6. The range, all the y's, 0, 1, 2, 3, and 4. Yada, yada. There you go. Okay, for this one here, same thing. Domain, all the x's. -3, -1, 1, 3, and 4. And then the range, all the y's, 1, 3, -2, 2, and 6. That's simple. If you find this hardest thing in the world, I swear to God, I'm going to go to your house and pluck up every single strand of hair from the top of your head, one by one, to show you how painful it is that you're thinking, that you're telling me this is super difficult. It's very simple. In fact, it's the most simple lesson I've taught so far. So stop it. Okay, moving on. Analyzing reasonable domain and ranges. Okay, reasonable domain and ranges. Okay, a function can model each situation. What is a reasonable domain and range for each function? A hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. Okay, domain could be the time, and a reasonable domain, a reasonable range would be from 0 to 10,000, right? So for this one right here, a restaurant needs to order chairs for its table. One table can accommodate 4 chairs. A domain could be from 0 tables to the number of tables that you need, and a reasonable range would be from 0 to 4, okay? Continuous and discrete. Continuous means if you cannot count every single number, including decimals, then it's continuous. If it's discrete, that means you can count the information on your hand, okay? So let's look at this here. The volume of water in the pool that can be determined by any point. Remember that volume can be also represented as decimal, so therefore, that's continuous. How about the number of tables and chairs? You can't have part of a table, you can't have part of a chair, therefore, it is discrete, okay? Here we go. Analyze each situation. Identify a reasonable domain and range for each situation, okay? Reasonable domain, I don't know, it could be number of games. And then your range, I don't know, the money that you're spending. Easy, your money that you're spending. Okay, a car travels 25 miles using 1 gallon of gas. The domain, this one's important, okay? The domain for this would be the amount of gallons or the amount of gas, but this is gonna be from 0 to 1. You can't go more than 1, and obviously you can't go less than 0. And the range, which is obvious, it's the distance traveled. Okay, very, very importante, okay? Here we go, moving on. Is each relation a function? If so, is it one-to-one? What one-to-one means is 1x to 1y, okay? So let's look at this here, okay? Is this a function, okay? Notice how the x's don't repeat, so yes, it's a function. And notice how there's only 1x for 1y, therefore it's 1-to-1, okay? This is also a function. Well, actually, it's not. Actually, yes, it is. So this is a function, but notice how there's only 3 y's with 5 x's. So it's not 1-to-1. Okay, here we go. Moving on. This is not a function. And the reason why it's not a function is that number 3 goes to 2 answers. Therefore, it's not a function. This is a function, okay? And notice how it's a linear function. That means only 1x gives you 1 y. That means it's also 1-to-1. Okay, here we go. We have, I think, a few more examples. The diagram shows shipping charges as a function of the weight of several online orders. Based on the situation, what constraints? You're limited. What constraints, if any, are the domain of the function, okay? An order must have a weight greater than 0. And what constraint means is you can't have negatives, right? Well, in this situation, you can't have negatives, okay? So in this case, we can basically say the constraint would be you need weight that's bigger than 0 in order to buy something, okay? Let's look at this here. Margaret has a monthly clothes budget of 50 bucks. She maps the amount of money that she spends each month to the number of items of clothing she buys. The constraint of the domain, okay? Her constraint. This is important. She cannot spend, so cannot spend more than 50 bucks. That's your constraint, okay? So since she cannot spend more than 50 bucks, she's limited to that amount. So therefore, that's your constraint, that ordeal. And guess what? We're officially done. Okay, that concludes that lesson. That concludes all of Wednesday. Good luck. Have fun. It's doable. You can do this. Enjoy your day.